Have you ever just felt completely buried under information? You're trying to get a really solid, well-researched answer to something complicated, and it just feels like wading through noise, cross-referencing, synthesizing facts, trying to make it all make sense. It takes so much time.
Mm.
But what if an AI could do that kind of deep, human-like research for you? Not just a quick search, but the real deal. Well, today, that's exactly what we're diving into, a pretty fascinating new framework from Google Cloud AI Research. It's called Deep Researcher with Test-Time Diffusion, or TTD-DR for short.
Yeah, and our goal here is really to unpack how this TTD-DR system works. Why is it such a leap forward compared to the large language model research agents we've seen so far? And what makes it so good at generating these really comprehensive, high-quality reports for complex questions? We'll get into the inspiration behind it, which is quite interesting how it mimics human thinking, its core mechanics, and yeah, the results it gets.
Okay, let's set the scene a bit. LLMs, large language models, they've obviously made huge strides. And they power these things called deep research agents, or DR agents. These agents can gather information, generate ideas, even draft reports. But the research paper we're looking at points out a really key limitation. They often seem to plateau.
Plateau. How so?
Well, when you ask them to generate really complex, long-form reports, they kind of hit a ceiling. The quality or coherence starts to dip.
Right, and that's interesting because most of these current DR agents, they rely heavily on techniques like chain of thought reasoning or these self-refinement loops, which are impressive in their own right. But the source material highlights that they lack a principled draft, search, and feedback mechanism that empowers human researchers. That suggests a pretty fundamental difference in their design compared to how we actually work.
So what's the takeaway there? It sounds like the paper is saying these agents don't really think like us when we tackle a big research and writing project. I mean, think about it. When you write about something complex, you don't just type from beginning to end, do you?
No, definitely not.
You plan, you sketch out a draft, maybe it's rough, and then you revise it, probably multiple times.
And crucially, during those revisions, you're often actively looking for new information, right? To plug holes, strengthen arguments.
Exactly. It's this back and forth. You write a bit, research a bit more, revise again. The paper even shows a figure illustrating this human process. Planning, drafting, revision, searching again.
Which brings up a really important question. Can an AI actually copy that iterative refinement process? The researchers apparently saw what they call a striking resemblance between how humans write and revise and how something called a diffusion model augmented by retrieval works.
Okay, diffusion models, like the ones used for generating images from noise.
Precisely that analogy. Imagine taking a really noisy, fuzzy image and gradually refining it step by step until it becomes clear. That's the core idea they applied to research reports. Start with something maybe incomplete or noisy, an initial draft, and iteratively refine it.
And that's where this test-time diffusion comes in, refining the draft during the process.
Exactly. It's about denoising that initial draft into a coherent final report, using newly retrieved information at each step.
Okay, now this is where it gets really interesting. TTD-DR is proposed as this novel framework that conceptualizes research report generation as diffusion process. So rather than just step 1, step 2, step 3, it starts with a preliminary draft. They call it an updatable skeleton. It's like a living outline that guides the whole process.
Right. And connecting that to the bigger picture, this draft isn't static. It gets iteratively refined through a denoising process. And the key part is this denoising is dynamically informed by a retrieval mechanism. So at each step, it's pulling in relevant external information to make the draft better.
Okay, so draft refinement and information retrieval are happening together iteratively.
Yes, and there's another layer. The whole thing is also enhanced by a self-evolutionary algorithm applied to different components of the agent's workflow. The goal is basically to make sure the context feeding into this diffusion process is super high quality. Every piece is optimized.
The source material has a figure showing this flow. Your query kicks off a preliminary draft and a research plan. And then it's this evolving draft working alongside the plan that dynamically tells the system what to search for next. It's not search then write, it's search and write, feeding each other.
It's like a smart researcher who jots down some ideas, realizes they need more info on point 3, goes, finds it, and then weaves it back into their notes, maybe even adjusting the overall structure. And this draft-centric design, as they call it, is what makes the report writing more timely and coherent. It also helps reduce information loss during that iterative search.
How does it reduce information loss compared to other methods?
Well, think about some other deep researchers like Hugging Face OpenDR or GPT Researcher mentioned in the paper. They often do fragmented searches for individual sections. That can sometimes lead to losing the overall thread, the global context. TTD-DR, because it's always working from and refining that single evolving draft, maintains coherence much better. It keeps the big picture in view.
Okay, that makes sense. So how does TTD-DR actually pull this off? What are the mechanics? The paper talks about a backbone deep research agent with 3 main stages. Stage 1 sounds straightforward. Research plan generation. An LLM takes your query and generates a structured plan, like an initial outline.
Right, the scaffold for the report.
Then stage 2 is iterative search and synthesis. And this is a loop, right?
Exactly. It's a continuous cycle.
First, an agent figures out what search queries to run. And importantly, it uses the plan, your original query, and context from past searches.
So it learns as it goes.
Yeah. Then, another agent uses a RAG system retrieval augmented generation to find and synthesize precise answers from documents, not just dumping raw text, but getting actual answers.
And this loop continues until the plan is covered.
Okay, and finally, stage 3 is final report generation. This agent takes everything the plan, all the synthesized question-answer pairs, and puts together the final report.
Now, underpinning all of that, to make sure the quality of information at each step is high, they introduce this component-wise self-evolution. This is an algorithm designed to improve the performance of the agents within each of those 3 stages: plan generation, search synthesis, and final report generation.
So it's like each part of the system is constantly learning and improving itself.
Kind of, yeah. Think of it as a continuous self-critique and refinement for each tool in the toolkit. The paper mentions it's inspired by recent self-evolution work like AlphaVolve. It's about making each component as effective as possible.
They give an example for the search answer generation part. It sounds almost like natural selection.
How so?
Well, it starts by generating multiple diverse variants of an output, like several different ways to answer a search query.
Okay.
Each variant then gets environmental feedback. An LLM as a judge gives it fitness scores, how helpful is this answer, how comprehensive, and also provides textual critiques, like specific suggestions for improvement.
Ah, so direct feedback on each attempt.
Exactly. Then there's a revision step, where each variant tries to adapt based on that feedback. And this loops: get feedback, revise, get feedback, revise.
Okay, iterative refinement within the component itself.
Right. And finally, a crossover step merges the best bits from the best revised variants into one final high-quality output for that specific query. It's quite sophisticated.
And the analysis shows this really pays off. This self-evolution significantly increases the complexity of the search process, which sounds maybe counterintuitive, but it leads to richer information gathered.
More complex search means better info.
In this context, yes. It means the system is digging deeper, considering more angles, generating more nuanced answers based on that evolutionary refinement. And that ultimately results in better final report quality. It ensures the building blocks are solid.
Okay, so self-evolution makes each component really strong. But the paper says even with that, they needed something more for timely and coherent information integration into the overall report.
Right, improving the parts is great, but you also need to integrate them effectively into the whole.
And this leads to this second big mechanism: report-level denoising with retrieval.
Yes, and this is where that diffusion analogy really comes into play again. Remember the noisy image.
Yeah.
This mechanism prompts an LLM to generate an initial draft report based on your query. And this first draft is intentionally seen as noisy or incomplete. It's the starting point for refinement.
Got it. So you have this initial, maybe rough draft.
Yeah.
Then what?
Then the magic happens. That current draft is fed back into the search stage 2A of that backbone agent we talked about.
Ah, so the draft itself helps decide what to search for next.
Precisely. It informs the generation of the next search query. Then, after an answer is found and synthesized in stage 2B, that new information is used to revise the draft.
So it might add new details or maybe verify something that was already there?
Exactly. It's constantly updating and refining based on the latest findings. It forms this continuous feedback loop where, as the paper puts it, the evolving draft guides the search and the search refines the draft.
That sounds incredibly dynamic.
It is. The source material even provides an algorithm showing this iterative revision. The draft is progressively denoised, step by step, until the search process concludes. Then, a final agent steps in to generate the finished report, using the whole history of revisions and all the retrieved answers. It's learning and writing simultaneously.
And this makes a big difference, doesn't it? The paper shows this denoising with retrieval increases query novelty by over 12 percentage points.
Which means it's asking better, more exploratory questions as it goes, prompted by what's already in the draft. It's not just sticking to the initial plan rigidly.
Yeah, and even more impressively, they found that with only 9 of these search and denoising steps, the system already incorporates 51.2% of the final report information.
Wow, that's efficient.
Right. It significantly outperforms just using self-evolution on its own in terms of how quickly it integrates knowledge. It means the information is being incorporated much more timely during the process.
So, connecting this all together, you have these two core mechanisms. The component-wise self-evolution, making each part strong, and then the report-level denoising with retrieval, integrating everything coherently and timely. And the combination leads to, well, state-of-the-art results, according to the research.
Yeah, the paper shares some pretty compelling numbers in its tables. TTD-DR apparently achieved superior results across all benchmarks they tested. For generating long-form research reports, it had win rates of 69.1% and 74.5% in head-to-head comparisons against OpenAI's deep research. That's a significant margin.
Definitely. And for multi-hop reasoning tasks where the AI needs to connect multiple pieces of information logically, it outperformed other competitors by several percentage points, too. These aren't trivial gains.
They also did an ablation study, right, where they tested the system with different parts turned off to see their individual impact.
Yes, and that really highlights the contribution of each piece. Basic LLMs with simple search tools show some benefit, obviously. Adding the backbone DR agent structure improves things further. Then, layering on self-evolution gives another noticeable boost. But it's really the addition of the diffusion with retrieval, that report-level denoising, that provides the substantial gains.
So it confirms that these two big ideas, self-evolution and diffusion with retrieval, are really efficient algorithms for test time scaling. They work, and they work well together.
Exactly. Each layer builds effectively on the previous one.
So bringing it back to the listener, what does this mean for you? What's the practical impact here?
Well, it means this framework, TTD-DR, can generate genuinely helpful and comprehensive reports for complex research questions. And it's shown promise across different areas: finance, biomedical, recreation, technology.
So think about maybe a financial analyst needing to synthesize complex market trends quickly, or a medical researcher trying to connect findings from disparate studies.
Right. This system, with its ability to maintain that global context via the draft, could potentially provide much more coherent and insightful narratives than we get from current tools. It's designed for those really tough, search and reasoning-intensive user queries.
The kind of questions that even the best current LLMs, using just their internal knowledge or standard search plugins, might struggle to answer fully or coherently.
Precisely.
So there you have it. The deep researcher with Test-Time Diffusion, TTD-DR. It's not just, another incremental update to an AI model. It feels like a fundamentally novel framework that rethinks how an AI can conduct good research, and it does so by drawing inspiration directly from how we humans think and refine our ideas.
Yeah, that draft-centric design, the idea that the report itself learns and refines as it's being created, rather than just being generated linearly at the end, that feels like the real game changer here. It leads to more timely information integration, more coherent outputs, and less information getting lost along the way. It's a significant shift.
This deep dive really does show how close we might be getting to AI becoming more like truly dynamic, adaptive research partners, doesn't it?
Yeah.
It really makes you wonder, how will advancements like TTD-DR change the way we approach complex problems, or sift through information in our own work, or even our lives? What other kinds of noisy drafts could AI help us denoise in the future? Maybe a complex business strategy, or a scientific hypothesis that needs constant refinement based on new data, or even just trying to make sense of a really difficult personal decision. Where else could this iterative refinement approach be applied?